Hey everyone, welcome back to part 12 of our SQL series for beginners, where today we are going to understand the most important topic of SQL, which is window functions. So let's dive in. So let's first understand what are window functions in SQL. So window functions perform calculations across a set of rows that are related to the current row called a window without grouping or collapsing the rows. So basically, window functions lets you perform calculations across some set of rows that are related to the current row. You can think it like this, that if, for example, just want to calculate the running totals, or you want to assign ranks, or even look at previous or next rows, that's where you make use of window functions. So the common use cases of window functions are finding running totals, assigning ranks or row numbers, or computing aggregations without collapsing rows or performing group by operations. The best part over here is that you don't need to use group by operation over here to lose any row details. So you can simply calculate running totals. You can compute aggregations like average or sum, all while keeping each row intact. So let's understand this with the help of an example. So here is our input table that has some order details information, having columns like order ID, customer ID, and amount. Now let's say we just want to know how much each customer has spent in total, but we don't want to collapse the rows. So using a window function, we will get this output where each row remains as it is and a new column, total spent, has been formed, which actually tells us how much the customer has spent overall. So customer A, as you can see from the table, customer A has placed two orders, that is of the amount 100 and 200, and his total shows as 300 in both the rows. While customer B has just placed one order with the amount 300, so their total is also 300. So I hope you're clear with a basic idea of what are window functions and how do they work. Let's now take a look at the syntax that you will make use for a window function while writing SQL query. So the basic syntax is going to be something like this, where we'll be writing the window function on some specific column name over partition by column name, and then we apply the order by, and then we just give it a new column. So that's how our window will be forming. So let's just take a look at each of the functions over here. So here, where window function is nothing but any aggregate or the ranking function, column name 1 is nothing but the column that needs to be selected, that we actually write in our select clause to retrieve the columns. So column name 1 is nothing but a column name. Then secondly, we are just writing the window function. It could be sum, it could be count, it could be min, it could be max, it could be either ranking function or whatever. We are going to explore all of these window functions in detail. Just take a look at the syntax for now. Then we have column name 2, which is nothing but the column on which the window function needs to be applied. Then here we can see that there is column name A in the partition by clause. So it is nothing but the column on which basis partition of rows will be done. And then you can see there is column name B on in the order by clause. So that is the column by which rows are ordered within each partition. And new column is nothing but the name of the new column that will be formed. In this case, it was total spent. In the example that we just discussed, the new column was total spent. Okay. And here the from table name is nothing but the name of the table. So that's how your basic syntax of writing a window function over here. So for the example that we just discussed, your SQL query would look something like this, where you will be writing select order ID, customer ID, and the amount. That will be the rows that we will be retrieving as it is. And next we are forming a window, which is nothing but the total spent, but since we just want to compute the total amount spent by each customer. So here, since the operation that we are doing is sum function, because we want to compute the total, so our window function is sum. Since we want to compute the sum of amount, so we are doing it on the amount column. Then over, we are just since we want to compute it for each customer, that's why we have written the customer ID in the partition by clause, since we want to compute for each customer the total amount spent. And here I don't need to make use of order by clause, so I have skipped that, and I have renamed this entire window function as a new column, which is my total spent from orders, since my table name was orders. So that's how you can write a SQL query. Let's now take a look at the types of window functions over here. So basically, I have categorized all the window functions into three major types. The first one is the common window functions that include sum window function, average window function, min window function, max, and the count function. So these are nothing but the aggregation functions. So it could be either sum, it could be either average, it could be either computing minimum or computing maximum or computing the simple count. Next, the second type of window function is ranking window function. There comes in row number, rank, and dense rank. So these are used to actually assign the rank. So these are the ranking window functions we say. And the last one are the value functions, which are lead and lag, that are actually used to access data from rows other than the current row within a specified window of rows. Lead and lag are SQL window functions that are used to access data from previous or the next rows within a defined set of rows. Okay, so that's where whenever you want to access data from the previous row or the next row, that's where you just make use of lead and lag window functions. So let's understand each of these window functions in detail, where first of all we had common window functions that includes all the aggregation functions like sum, average, min, max, and count. So here sum is used when you just want to add up values within a window. So that's where we just make use where, for example, you just want to calculate the total. So that's where sum function is used. For example, when you just want to calculate the total sales per customer, or let's say total salary in a department, or let's say running totals of orders. So that's where you will make use of sum window function. Next comes the average window function. So average is used when you just want to return the average value within a window. It could be like when you just need to find the average score of a student, or it could be average monthly salary or average transaction amount by customer. So that's where you just make use of average window function. The next one is the minimum value function. So this is used when you just want to return the minimum value within a window. For example, you just want to find the first purchase amount or the lowest salary in a team. It could be earliest transaction date for each user. So that's where in such cases you make use of minimum value window function. The next one is the maximum value window function, which is used when you just want to return the maximum value within a window. So the use case of this window function could be like when you just want to compute the highest order value, or you want to find the top salary in a department, or it could be the latest date of transaction for each customer. That's where you make use of max window function. The last one is the count window function, which is used when you want to return the number of rows within a specific window. So for example, it could be used when you just need to count how many orders a customer has placed, or how many employees are there in a team, or how many visits are made by a user. So these could be the examples where you will make use of the count window function. So we can say that each of these functions becomes much more powerful with the over clause that we just see in the syntax. They actually let you analyze data in context without losing row level details. So remember that window functions don't group or collapse data. They just let you keep all the rows intact while still doing calculations across them. Let's now take a look at each of these aggregate functions in detail with the help of examples. So first of all, we'll take a look at the sum window function here. So here you can see in the input table, we have three columns, that is the employee, department, and the sales amount, where each row tells us how much sales an employee has made and which department the employee belongs to. Now let's say you just want to know the total sales made by each department, but you still want to keep all the individual rows. So that's where we'll make use of sum window function with the partition by clause. So here in this case, our output would look something like this, which actually gives us a running total per department while keeping the original rows intact. So you can see the table over here that the department A employees, that's Naira, Vihan, Meher, all show 450, which is the sum of 100 plus 150 plus 200. While department B employees, which are Arjun and Sanvi, both show the department total sales is 700, which is nothing but the sum of their sales amount, which is 300 plus 400, which is 700. So when we write SQL query for this, it would look something like this. So here we are making use of sum window function on the sales amount column. We just want to compute the total sales. That's why we are making use of sum window function on the sales amount column. And here we are doing the partition by clause on the department column. That means we just want to group the data by each department, but since we don't want to collapse the rows, we simply want to compute the sum in a new column. So that's why here we have done the partition by on the department column, and then we have given the complete alias for this new column as department total sales. Okay, so yeah, that's how you can compute the department level totals without writing a group by and without losing the row level details. Let's look at the second example where you will computing the average sales for each department. In the first case, we were computing the total sales for each department, and in this case, since we want to make use of the average window function, so in this case we are computing the average sales for each department. Okay, so here again we have the same table of employees, their departments and their sales amounts shown over here. Now since we want to compute the average sales per department, and yeah, that we just want to display it alongside each employee. So your output would look something like this, where you can see that the new column, which is department average sales, have been created over here. So it actually helps you to compute the average of sales amount for each particular department, where we have simply written average of sales amount to calculate the average, and we have done it over partition by department, means that the average is grouped by department. But unlike group by, you don't lose the original rows here. Similarly, you can also compute the minimum and maximum of sales for each department, although I'm not going to discuss this in detail over here. But you can simply write minimum of sales amount over partition by department. That will compute the department minimum sales. And similarly, you can compute the maximum sales for each department as well, while writing the maximum of sales amount over partition by department as department maximum sales. So that will display for each employee, it will display the lowest and the highest sale in the department. Similarly, you can also count how many employees are in each department using count window function, where you will simply write count window function on the employee column over partition by department. That will actually compute the count of employees for each particular department. So that's how you can make use of the common aggregate window functions over here. Let's now move on to the second type of window functions that we discussed, which are ranking window functions. So as we know, ranking window functions assign a ranking or row number to each row within a partition. So here we have three major types. The first one is row number, which assigns unique row for each partition. The second one is the rank window function that assigns same rank even for ties, and it skips the ranks. And the third one is the dense rank, which actually handles ties. That means it gives same rank for ties and does not skip the next rank. Let's understand more about each of them using example. So here the first one is the row number window function. So here we have, so as we know, row number window function gives unique rankings to each row within its partition, even if two rows have the same salary. So let's understand using an example. Here we have a table of employees. So it contains the columns like employee, the respective department, and the respective salaries. So here, let's say you just want to assign a rank within each department based on who earns the most. So the person who is earning the most should ideally get the rank as 1. So here we'll make use of the row number window function, and let's see how it actually works. So here your output would look something like this. So here since we want to compute, we want to assign rank within each department. So here if you see, there are majorly two departments. Department A having 3 employees, Isha, Kabir and Myra, and department B having 2 employees, Rohan and Tara. Where you can see that Isha and Kabir having the same salary, which is 80,000. And in the output, you can see that the rank that have been assigned using row number function is 1 and 2. Ideally, it should be 1 and 1. But here, it is 1 and 2. You might have noticed. So here, it is important to notice that even if two people having the same salary like Isha and Kabir, they get different ranks as 1 and 2. Similarly, in the department P, as you can see, Rohan and Tara both are having the same salary, which is 60,000. Still, they get ranked as 1 and 2, which is purely based on the order they appear after sorting. So even if values tie, row number does not care. It just gives a unique new number to every single row. Okay, so that's how row number works. So row number always gives a unique number even if there are ties. Okay, even in the case of ties happen. So if when we just want to write a SQL query for this, that is how you will be writing. So here you will simply writing the columns that you want to extract, which is the employee, department, and the salary, and the new column that you will be creating. So here since here we will make use of row number window function. So row number over partition by on the department, since we want to assign rank for each department. So here since we want to assign ranking for each department based on each department, so here you are writing the partition by department. And since you want to make sure that the highest salaried employee should get rank 1, so here you have done the order by on the salary column, and that too in the descending order. Okay, so that's how you make use of you write the window function like this, and here you are just giving the alias of this column as row number, which is nothing but the alias of the new column that you just created. Okay, by assigning the row numbers. So yeah, that's how you just need to write the SQL query. Let's now try the same query with the rank window function instead of row number. So here, as we know that ranking, so here in this case again, we will be ranking employees based on their salary in each department. Since we want to rank employees based on their salary in each department, using rank window function, so it's important to know that what rank window function actually does. So rank window functions gives the same rank to ideal values. It could be either ties, but it actually skips the next ranks when there are duplicates. So let's see how it works. So here, as you can see, you have the same table, which is the respective employee table having employee, department, and the salary. And here is the output table where you can see that you will apply the rank window function. So here what you will be getting is having the same salary, which is Isha and Kabir. So yeah, Isha and Kabir having the same salary are getting rank 1, which is ideally true. But as you can see here, the Myra, which is having the salary 70,000, is getting rank 3. Ideally it should get rank 2, but rank window function actually skips the rank. Since we have given the same rank to 2 employees over there, so it has skipped the second rank and it has moved on to the third rank. So this happens because rank actually skips the next rank when there is a tie. Okay, so the skipped rank accounts for the number of people sharing the previous rank. That is one important thing that you need to know, that the skipped rank accounts for the number of people sharing the previous rank. Okay, so when we'll write the SQL query for this, your SQL query would look something like this. Since we want to compute the ranking of employees based on their salary in each department, so here we are simply retrieving the 3 columns, that is the employee column, department column, and the salary column. And next we are making use of the rank window function over partition by department, since we want to compute for each department. And here you are doing order by on the salary, which is descending order, since we want to make sure that the employee having the highest salary should get the rank 1. Okay, so yeah, your new column, so we have now given the alias as rank in department. So the new column that has been formed over here having the column name as rank in department. Okay, so yeah, you can see that there is big difference between the row number and the rank window function that we just discussed. What rank function does is it gives the same rank to tied values, but it skips the next number. And what row number does is it simply assigns a unique number to each single row. Okay, even if there are ties, it does not care. It will simply assign ranks like 1, 2, 3 like that. Okay, Now let's finally make use of the dense rank window function. So let's see what dense rank does is. Okay, so here again we are simply taking the same example of the employee's information, and here while applying the dense rank you can see the rank. Just take a look at the rank over here. So here you can see that the same rank has been assigned to Isha and Kabir, which is 1 1, and Myra has ideally got rank number 2. So in this case it does not actually skips the rank. So dense rank is like similar to rank, but it also assigns the same so dense rank is like a more dense rank is ideally more better than rank. Okay, so it does not actually skip any numbers even after a tie. It has given the rank number 2, which was ideally true. Okay, so that's how so I hope it's clear between the dense rank and the row number. So dense rank does not skip any numbers even after a tie. Actually assigns the same rank to ties but does not leave the gaps, just like rank does. Okay, so while writing the SQL query for this, the SQL query would look something like this. Again, here we are making use of dense rank window function over partition by department, since we want to compute the rankings based on each department. That's why we are making use of partition by on the department column, and here we are doing order by on the salary, making sure that the salary should be descending, that is the highest salaried employee should get rank 1. So here we are giving the new column alias as dense rank in department. So that's how your SQL query would look from the employees table. Okay, so let's just wrap it with a quick comparison between row number, rank and dense rank. So in summary, row number does not handle ties, does not skips the rank, while rank gives the same rank to the ties and it also skips the rank. But the dense rank gives same rank to the ties and does not even skip the rank. So you can use row number when you need unique positions, and you can use rank or dense rank when ties matter. But if you want to skip the rank, please make use of rank window function. If you don't want to skip the rank, make use of dense rank window function. So that's how these window functions work. Let's now take a look at the last type of window functions, which are value functions, ideally, which are lead and lag. So here, lead, the syntax of lead window function goes like this: lead column comma offset, which actually returns the value from the next row, and lag column comma offset, which actually returns the value from a previous row. Now let's see what is offset over here. So offset is nothing but simply the number of rows forward from the current row from which you want to fetch the value. Okay, so here the default value of, so here the offset is optional. The default value of offset is 1. You can also set a default value to return when there is no row at that offset. Okay, so let's understand each of these two window functions in detail using example. So here you have the example where you want to find the marks of the previous student and the next student. You are given some student information having roll number, name, respective name and the respective marks of that particular student. Okay, now you just want to compute the marks of the previous student and the next student in the new column. Okay, so here your output should look something like this, where you are having the information that you already have, which is roll number, name, marks, and you have created two new rows, two new columns over here, which is one is the previous marks, which actually gives you the previous student's marks, and the new column which is next marks, which gives you next student marks. So here if it is 80, so here we don't have the previous student, so the marks for the previous marks are null. For the 75, the previous student marks was 80. For 90, the previous student marks was 75, so here 75. Similarly for 85, previous student marks was 90, which was Chetan's marks, and similarly for 95, the previous student marks was 85, which was for Disha's marks. Similarly, it's compute for the next marks. So here for 80 we have 75, which is Bina's marks. Now for 75 we have Chetan's marks, which is 90, and for 90 we have 85. For 85 we have 95, and for 95 we have null, since we don't have any next student over here. So that's how your output would look like. So let's see how we are going to write a SQL query for this. Okay, Since we just want to since here in this case the default value of offset is 1, since we only want to skip one row, and we only want to compute the marks of the next student and the previous student, so the default value of offset is 1. So here we have actually made use of lag window function to compute the previous student marks, and lead window function to compute the next student marks. So here we are using lag window function on the marks column. Over order by we are making use over here, since we don't want to compute it. So there is no case of partition by here. So we don't want to separate it for each student or for each. There is no scope of using partition by clause over here. So here since we want to compute for each roll number, so here we have done order by operation on the roll number column for 1, 2, 3, 4, 5, making sure that since if you want to compute the previous marks and the next marks of each student, it is very important for us to make sure that the row numbers are assigned in the descending order. Okay, so here you have written order by roll number as the previous marks and order by roll number as the next marks from the students column. So I hope you are clear with the window functions, lead and lag. So that's all I wanted to share in this video, guys. I hope you are clear with the syntax and the types of window functions and how to write SQL query making use of the window functions. So that's all for this video, guys. Thank you, and let's meet in the next video. See you soon. Bye bye.